Okay, hi everyone. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy and which is India's largest online learning platform for IIT JEE. Now, this is a series that I host for Class 12 students, and the topic that we are starting today is EM waves. And this is lecture number 1 of EM waves. So today we'll be mostly talking about the introduction of the topic, and we'll go over some basics. So hello Shivam, how are you? Hi Rohit Yadav, and hello AP. Good to see you guys. So yes, there was a slight technical glitch at my end, so because of which the stream was not starting properly. Anyhow, so now we're fine, I guess. So before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for the IIT JEE exams, both mains and advanced. And I myself, as a student, was All India rank 447 and All India rank 182 in the two stages of the IIT JEE exams that I took. So we used to have the IIT JEE exam in two stages. The first was the qualifying stage, which was an objective paper, and finally was the selection stage, which was a subjective paper. So in the first objective paper, I secured an All India rank of 192, and in the second subjective paper, I secured an All India rank of 447 and finally got admission into IIT Delhi. Now, as a student, I also qualified NTSC Stage 2 and I was in the top 1% in the NSCP. Now, I've already coached many students to top ranks in the JEE exams and other exams as well. And now, sir, मैं attend कर लूँ या practice करने जाऊँ? Okay, I think Shivam, so this is not really going to help you much because you are a class 11 student, right? So it's better अगर आप practice करो. By the way, I have planned some practice sessions for the next 3 days. Okay, so Wednesday, Thursday, and Friday we are going to have some discussion plus practice sessions on the app. Okay, special classes have been planned, so make sure you are attending those, by the way. Okay, so hi Rajesh, how are you? All right, so as I said, before this year, all my teaching had been offline. Now this year has forced all of us to adapt, and I have moved to online teaching. That is what you guys can also do as students, right? You guys can get yourselves the Unacademy subscription. This subscription will give you benefits like live classes. You'll get to interact with your educators, and you also have live polls and leaderboards in these classrooms, which keep them highly interactive and fun. And of course, you have test series and analysis sessions, which make sure that your studies are not only going uninterrupted, you're also getting regular testing, which is very important for a competitive exam like JEE. And of course, you have the live doubt clearing sessions, which is a great feature. So, for those of you who don't know this, after every 3 teaching sessions, every Unacademy Plus course has to have a live doubt clearing session. So, we at Unacademy Plus will make sure that your doubts never pile up. Okay, so sir, timetable share कर देना please. Advance में timetable बनाना पड़ता है, please, humble request. Okay, so I think if you are following me, you would have gotten the notifications. You can check it out. I think the next 3 days we are going to have these sessions from 6:30 to 8. Okay, Wednesday, Thursday, and Friday, and then Sunday from 2 to 3:30. Okay, I've already planned that, and don't worry, those classes haven't published. So if you're following me on the app, you should be able to see that. Okay, all right. So as I was saying, now on top of all these benefits, Unacademy is also providing you the chance to study from the India's best educators, all across India, from the comfort and safety of your home. Now from your home, you can study from any of the top teachers all across India. So that is a huge opportunity. Again, this is not something that you will come across anywhere else. So make sure you are getting using these opportunities definitely. Use code RDSC for giving back to society. Yes, and RDLive also. I have two codes, by the way. So there are two methods in which you can give back to society. Use the code RDSC or RDLive, by the way. Okay. Anyhow. So the first step towards getting this subscription would be to install the Unacademy app. The moment you do that, you unlock free features. Okay. So there are a lot of free courses available on the Unacademy app. So the moment you install this app, you will get access to free courses plus special classes. Okay, that is again available for free. So that's what I was telling Shivam. So tomorrow onwards, we are going to have four special sessions this week for rotation, discussion, and problems. Okay. Then you guys can also, anybody can attend that as long as you have installed the Unacademy app. That's all you need to enter those sessions. Now you also have quizzes, free quizzes. So make sure that you are installing the app and at least unlocking these features. Okay. So trust me, all these features will help your JEE preparation get boosted. Now, once you have done that, once you've accessed all the free features, that will give you a flavor of how it's going to be when you get yourselves the plus. Okay, so if you like the free courses, and if you think that you would want to enroll in the plus courses, then this is what you do. You can go to the plus section of the app, select your goal as IIT and click on that get subscription button. Now, the moment you do that, you'll be redirected to the payment page where you can use the code RDLive. Again, so as Shivam said, this is your chance to show some love back. If you like my lectures, if you like to enroll in my courses on Unacademy Plus, you can get your subscription using that code RDLive. Okay, so yes, that is your chance to show some love back to from me, okay, for your teachers. Now you can choose from two course types of subscriptions. You can either go for a plus subscription or an iconic subscription. The plus subscription enables you to access all the features of the Unacademy Plus. You have full access to all the Unacademy Plus courses. You can enroll and take your journey the way you like it. Now, if you want somebody to guide you through that journey, then you can go for the iconic subscription. Okay. Now, let me also point out here that when you click on proceed to pay, you also have a lot of no-cost EMI options, which will benefit you in case you're finding that this payment is a little steep. So you don't even have to make this payment in one go. You can break it into a lot of no-cost EMIs with no extra cost. Okay, so break it into smaller payments, which don't make you feel the burden of this. In any case, the fees of the subscription has been kept pretty competitive compared to what people pay in any of the offline setups. So if you realize 24-month subscription is coming out to be roughly 2,100 a month, and 12-month subscription comes out to be around 2,800 a month. So you will realize that people are paying way more than this for their tuitions, okay, at home, okay. And all the coaching will charge you, any reputed coaching will charge you somewhere between 4 times to 10 times this fees. So at these prices, I think the subscription is a must-have. So get it as soon as possible, and don't forget to use the code RDLive, okay. Now let's talk about the iconic subscription a bit. So as I said, with the Plus subscription, you have access to all the features. Now you are free to choose any course that you feel like. You are free to guide your JEE journey the way you like. But if you want somebody to guide you, mentor you, or full time, then you can go for the iconic subscription. So this subscription will take your JEE preparation to the next level with personal coaches. So you'll be assigned personal coaches who will guide you what courses to take, when to take, how to plan your studies. You will also be a part of IIT workshops. You will receive timely expert guidelines. You will get a study planner which will tell you, बाय जाके रिमाइंडर लगा देता हूँ आपकी क्लास के लिए, सी यू सून. Okay, sure. All right, bye bye. Take care, Shivam. Now, study planner is again a huge advantage because, in my experience, a lot of students struggle with that. They can't manage their studies. So here, you will get a study planner, and your mentors, your personal coaches, will keep track of your performance. Will make sure that you're following that study planner. Then, of course, you have test analysis sessions. All these features will give you a much more personalized guidance. So, if you want a very personalized, highly personalized guidance towards your preparation, and you want to make sure that somebody is constantly mentoring you, then you can go for the iconic subscription. Now, you also have a chance to win yourself these subscriptions by competing in the Unacademy Combat. So this is the most competitive gamified battle of IIT JEE. Hey, hello Ananya, how are you? So I hope you did well in your paper. How was it? How was it? Yesterday you worried about your paper, right? Okay. So next Unacademy Combat event is going to happen live on the 20th of December. You can enroll in that using code RDLive. Do well and win yourself some cool prizes, including a lot of Unacademy subscriptions for completely for free. All right, those of you following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So this will make sure that you're receiving all timely notifications of all the sessions and lectures happening here on the JEE English channel so that you don't miss out on anything. Okay. Next, so why don't we get started with the topic now? So today, as I said, we'll be starting a new topic, which is EM waves, electromagnetic waves, that is. And this is lecture 1 of electromagnetic waves. Mainly, we'll be talking about introduction to as to what electromagnetic wave is, how they are formed, and what are their characteristics. Managed to grab 50 out of 70 somehow. So that's really well done. Congratulations. See, you were worried for nothing. So I keep telling students, instead of worrying, just start studying. Okay, because worrying will never help you. You study, you will be surprised what you can manage. So great, well done. Just try to memorize derivations. All right, sure. Very well done. I'm glad you did well. All right, so as I was saying, so let's introduce the topic. So what is an electromagnetic wave? So a changing electric field, you will realize, produces a magnetic field, okay, and vice versa, which gives rise to a transverse wave, which is known as an electromagnetic wave. So that is what you have as a picture here. This is what a typical electromagnetic wave looks like. This is the wave representation. So electric field in one direction is oscillating in magnitude. Okay, so the magnitude is going from plus some EY to minus EY. So the electric field at any point, if you notice. So if I focus on one point, so the electric fields here will oscillate from plus EY to minus EY. So they are constantly changing. At the same time, the magnetic field is also changing. Okay, and you will realize that these changes are happening in phase. So both of them achieve their maxima at one go. Both of them get zero at the same time. Both of them get to their maximas on the opposite directions the same way. So these oscillating electric and magnetic fields, when they travel together, this is what we call an electromagnetic wave. You know that electric fields carry energy, magnetic fields carry energy. So when these oscillating fields are traveling together, they are in fact carrying energy and momentum both in fact. Okay, so that is what an electromagnetic wave is. Now, a time-varying electric field and magnetic field mutually perpendicular to each other are also perpendicular to the direction of propagation. So that is what you will notice about them. So if you have a wave which is traveling, say, in the x direction, if the electric field has variations along the y direction, then you will realize that the magnetic field will have variations along the z directions. So the directions of the two variations and the direction of propagation are always mutually perpendicular. That is something that we can prove also later. Okay. So an electromagnetic wave essentially consists of a sinusoidally varying electric field and magnetic fields acting at right angles to each other such that it is also perpendicular to the direction of propagation. Okay, so I think you should get an idea of an electromagnetic wave with that picture that we have shown you. Okay. Next, let's talk about the history of electromagnetic waves quickly. So in the year 1865, Maxwell predicted that electromagnetic waves should exist. He proposed that there should be such waves which will consist of oscillating electric and magnetic fields, which will oscillate, and their oscillations would be perpendicular to the direction of the propagation. According to him, how is an electromagnetic wave produced? So he's proposed that any accelerated charge. So whenever the charge accelerates, it sets up a magnetic field in its neighborhood. Right? We know a moving charge is essentially equivalent to a current flowing, right? So accelerating charge will actually behave like a variable current. A variable current would have produced a time-varying magnetic field in its vicinity and also a time-varying electric field. So that is what he suggested. He suggested that if you have an accelerating charge, then it will establish time-varying electric fields and time-varying magnetic fields in its vicinity, and these fields can propagate, and this is what he proposed would be an electromagnetic wave. Now, in 1887, Hertz actually produced these waves in a lab, okay, using LC oscillations. So that was a very interesting experiment. Okay, maybe you can read up about it. So Hertz actually produced and detected EM waves experimentally with a wavelength of about 6 meters. So he had an LC oscillation setup, and he realized that setup where the charges are oscillating constantly, so that can produce EM waves. Now, in 1896, Marconi also discovered that if one of these spark gap terminals is connected to an antenna, then the other terminal is Earth, then electromagnetic waves are radiated, which could go up to several kilometers. As you know, Marconi was the guy who invented the radio. So radios, work on radio waves, which are essentially electromagnetic waves. So Marconi also did some experiments and proved the existence of, electromagnetic waves, and also suggested that these can travel up to a long distances. So trust me, EM waves is a very, very important phenomena in our life. Light is an EM wave. Okay, heat, mostly infrared rays, are EM waves. All your communication works on EM waves. So without EM waves, trust me, if EM waves did not exist, our life would have been hell. Okay, in fact, your microwaves, they have EM waves. Okay, microwave ovens. So there is a huge significance of EM waves in our lives. Let's get to know more about that. So how are these waves actually generated? Let's talk about it in slightly more detail. Now, electromagnetic waves are emitted when electrically charged particles undergo acceleration. Okay, the most common example that you see is, you will know that most of our matter behaves as dipoles, right? So a lot of our matter behaves as dipoles. We know that. So if you take up any molecule, let's say, so any molecule will consist of these dipoles, right? A positive end and a negative end. And you know that all the matter, in all the matter, the molecules are never at rest. They are constantly vibrating about their mean positions, right? So you would have, if you remember that from your thermodynamics, right? All matter, all molecules are constantly vibrating. In solids, at least, they are vibrating about their mean positions. In air, they will be moving in random directions. So they are constantly accelerating. So let's take up an example of a solid made up of a lot of dipoles. So imagine a dipole which is oscillating. Now, you know, dipoles can create electric fields along their axes and also along their equatorial planes, right? So imagine, just take up a simple example. Just imagine a simple example where I had a point charge. If I had a point charge like this, and if you connected this to a thread, what would you have noticed? So if there was a charge Q here, would have produced some electric field in its vicinity. Okay, so you would have seen that the entire area would have had electric fields, right? Now, what happens if I start oscillating this charge? Now think about this. If I start moving it like this, so the moment I am moving it towards these points, so you realize when it is moving here, the electric field will get stronger. Right? So if the electric field here has had some magnitude, it will go up, okay, above the magnitude, the average magnitude, which would have been when it was here. So when the charged particle comes closer, the magnitude of electric field is going up. Next, if you take it back, then you will realize that this magnetic electric field will start to go down. And when it is at its other extreme in oscillation, then you will realize that the electric field would be minimum. So when this charge is moving like this, you realize this electric field about a mean value. So let's call this E mean. About its mean, it starts to vary with some plus E naught and minus E naught. So E naught being the amplitude of variation, right? The maximum field would become EM plus E naught. The minimum field would have become EM minus E naught, because if it is oscillating, then about the mean position, it will go in either directions by the same distance. So when it comes closer, the field increases. When it goes farther away, then the field decreases. So such an oscillation of any charged particle would produce variations in the electric field in space. Okay. Okay. So ARJ says, so dates have finally been announced. Okay. 22nd to 25th of Feb. Registration has started. Don't know if I should be happy or sad. Why? Why such a confusion? Why is there such a confusion, ARJ? So dates were supposed to get announced sooner or later, right? So now at least you know you should be happy. Now you can plan things better. No, now there is no uncertainty. Hello, Aftab, how are you? No, ARJ. I personally think you should be happy about this. Okay. So what you realize here is that when the charges are moving, so they are producing some electric fields, right? Electric field vector. And the magnitude of this electric field is varying. Now, a moving charge and oscillating charge, in fact, will have different velocities. It does accelerate, right? So a charge which has a variable speed will produce a variable magnetic field also, right? Because I hope you remember we had described this. A moving charge can produce a magnetic field dB vector equals to V cross R over R cube, right? So if you realize that when the charge is oscillating like this, when a charge is oscillating, it will not only the R will vary, the V will also vary. So because of this, the magnetic field produced at any point would also start varying. Yes, Neetu Chaudhary. So how should that be a worry? Don't worry about it. Okay. So this is a new channel. Probably a lot of people don't know about this. Okay, so that's why, I guess. Okay, anyhow, so you realize that from these two equations that a charge, if it starts to oscillate about its mean position, it would create variations in the electric field and the magnetic field that are being produced in its vicinity. Now you will realize that the mean value, strangely enough, the mean value over a long distance would go down to zero, right? You know that if I move infinitely away from a charge, then the electric field would essentially drop down to zero. However, what you will notice is that these variations never stop. These variations can travel up to long distances without diminishing. Okay, So that is what an EM wave is. After a huge distance, in fact, you will realize that the average value of electric field would have gone down, and you would have just noticed the variation of electric and magnetic fields traveling with the mean value of zero, in fact. Okay, that is how you realize that light can travel from the sun to the earth over such long distances. Also, electric fields can travel, and how does that happen? That happens because the varying electric field is able to sustain variations in magnetic fields and vice versa. So both the varying fields are actually sustaining each other, and that is how they can propagate for a long distance. Okay, now that is how essentially an EM wave is generated. Now, in most of the matter, if you remember your thermodynamics, we talked about radiation. Every matter emits radiations, right? And radiations were mostly emitted in form of EM waves, correct? So that is why all matter is producing radiations. So most of matter is comprised of dipoles. Okay, even if it is electrically neutral, most of it is in dipole form, and these dipoles are constantly vibrating. So this is called a dipole oscillator, by the way. So these dipoles oscillating produce magnetic fields, electromagnetic waves, which in fact constitute radiation, which is emitted by all matter. Okay, so ARJ says, sir, right now my 12th syllabus is done except chemistry. Okay, one left. Okay, so I have approximately 3/4 of 11th. If I focus only on 12th as of now, will it be possible to cross the cutoff? Okay, so all right, ARJ. Hmm. All right, ARJ. If you focus only on 12th, see some part of 11th you must remember, right? I'm hoping some part of 11th. It's not like you would have completely forgotten your 11th, right? If you had studied well, then some concepts you would have remembered, right? Especially like you can't forget something like Newton's laws or energy conservation or momentum conservation, right? Yeah, don't worry, that never happens. That never happens. uh, Cutoffs never get skyrocketed, even when every time people expect that. I've seen cutoffs majorly remain the same. They cutoffs only depend on the level of the paper. If the paper is very easy, then only the cutoffs will go higher. If the paper is very difficult, then only the cutoffs will go lower. Otherwise, trust me, it never changes. See, the percentages remain the same, even if the absolute number increases, even if the number of uh, contestants or number of aspirants increase, okay, then also you will realize that the cutoffs will still remain the same because the percentages will never change. Out of every 10 students, if one is performing like this, so from every 10 students, again, the same thing would happen. Okay, so trust me, the cutoffs really don't skyrocket. They may just fluctuate a small bit, not really a huge impact is going to happen on them though. Okay, so if you focus on class 12, so see, almost 55% roughly questions are asked from your class 12 syllabus. And let's assume that even if you're not completely revising your class 11 syllabus, you'll still have a fair amount of idea about most of the topics, right? Especially for instance waves, when you're studying wave optics, so some phenomena of waves you already remember, right? The 11th In 11th I actually didn't focus on physics. The physics faculty that I had was not good. She used to read out the derivations and only did derivations. So what should I do for physics? For chemistry and maths I can somehow manage. So what you can do is you can try to just go through the quick revision series that I am hosting for JEE aspirants. Okay, hopefully that will help you remember some bits. And for right now, just stick to that. If you want to study a topic in detail, if you feel that some topic was weak, then that topic you can watch the extended lectures for class 11th and 12th also. Okay, so that would be my advice. And it is fine if you focus on 11th, if you focus more on 12th, because that will help you in your boards also, right? So in your first attempt, what you can do is you can focus on your 12th more, but do have some kind of revision for 11th. Okay, and if you do that well, don't worry, I think you still stand a chance to score 60 to 70%. Okay, if you do that well, that's all right, your concerns are always my priority. Okay, RJ, don't worry. So as I said, if you do this well enough, you can still stand a chance to score somewhere around 60-70%, which will be way above the cutoff. Okay, but again, that will still require a lot of hard work. Okay, all right. So good luck with that. Next, now before we start our analysis and understanding of EM waves, we will talk about something new. A new concept was introduced, which was called displacement current. So what exactly is displacement current? Let's try and understand this new idea. Okay. So you will realize when a capacitor is allowed to charge in, in an electric circuit, the current flows through the wire. So here a wire must be carrying some current for charging the capacitor. The current will be carrying some positive charge here and some negative charge from here, right? So this kind of current must be flowing in the circuit. And the charger, as the capacitor charges, you realize charges are getting accumulated on the plates, right? And because the charge on the plates is changing, you realize the electric field created inside or between the plates is also varying. Okay, I hope you can realize that. I hope you remember that this E, electric field between the two plates of a capacitor, was sigma over epsilon zero. Now, as the charge is increasing, your sigma is changing. That's why the electric field between the two plates would start to vary. Okay. Now, the point is that this changing electric field produces is produced between two capacitor plates. And now, according to Maxwell, this changing electric field intensity is equivalent to a current that is flowing through the capacitor. And this is what he called displacement current. Okay. So what happens is if you perform experiments and if you put a magnetic needle here, so strangely enough, the magnetic needle kept between the plates of a capacitor which is getting charged shows deflections. So if that magnetic needle is showing deflections, then you realize then there is a magnetic field. Now, since there is a magnetic field, if you started to apply Ampere's law, now Ampere's law tells you that integral of B dot dl would be equal to I enclosed times mu naught, right? And now, since there is a magnetic field, so when you take your magnetic needle at different points of this Amperian loop, so consider I'm taking this Amperian loop and I'm placing the magnetic needle at all the points of this. So I realize I will see deflections which will show me that there is magnetic field at all points. We have circular magnetic field lines. However, what is the current enclosed? There is actually no current enclosed physically, right? Because this space is empty. So now the problem is that how is this magnetic field getting produced? Okay. All right. So then one last question. If I have to do some chapters of 11th, which would you recommend other than KTG plus thermo? I will definitely do those as they have high weightage. So of course the mechanics is a must, I think, and thermo and waves. These are the three most important topics for class 11. Okay, your mechanics up to rotation, then maybe fluid and gravitation, maybe you can skip, because see, most of the theory of gravitation is very interlinked to your theory of electrostatics. So gravitation gets taken care of there only. Similarly, fluids, not a lot of questions are really asked. So compared to the other topics, that is, I'm not saying that you won't have too many questions from fluids, you may, but the number of questions is to the amount of theory that you want to study would not be comparable. So you can, since, okay, this is only for ARJ, okay, this is not a general advice that I want to give to people, but only for ARJ who says that he hardly has any time. So he has no choice but to be selective about his topics. I always tell students all topics are important, do all. But in case you don't have that much time, you can ignore gravitation, solids, and fluids. So elasticity chapter, gravitation, fluids, those can be ignored from the syllabus. Worst case scenario. So hello, Mohammed Aziz. How are you? Good evening to you as well. Okay, but that should be a last resort. Okay, if you are absolutely in trouble, then only do that. Waves is pretty important. Waves will help you with your wave optics also, and AC also. A lot of analysis is very similar. So I think waves, you shouldn't take too much time in studying waves. Okay, all right. Okay then, ARJ. All right, so let's get back to our discussion. So as I said, So I am getting a magnetic field in this region, but there is no current enclosed. However, my Ampere's law tells me is that Q dot I enclosed to be equal to closed integral B dot dl. Now I will realize that this term is non-zero for this region. Now, which essentially implies that this equation says that there should be some current. So that is what Maxwell said. Maxwell said that the changing electric field that is existing in the middle of these plates, that is the one which is behaving like a current. Okay. And hence it is able to produce a magnetic field. All right. So most welcome here, Muhammad Aziz. So what class are you in? What class are you in? So that was Maxwell's idea, by the way. That's why Maxwell said that this changing electric field actually is equivalent to a current, because according to Ampere's law, it is showing that there has to be some current, okay, because this is non-zero. So this is an imaginary current, of course, but the idea is that the changing electric field can behave as a current and produce effects of a current. So one very important effect of a current is that it can produce magnetic fields, right? That is what a varying electric field can also do. See, as I keep telling you, in physics, there has been symmetry throughout the history. Okay, so you are in class 11. All right. Please explain your schedule. So I take, okay, so my schedule right now is slightly complicated. So I take class 11th topics on Mondays and Wednesdays at 4. Okay. Then class 12th topics on Tuesdays and Thursdays again at 4. And right now we are having a revision series. Okay. Oh, thank you so much. We are having a revision series. So revision series for JEE aspirants of 2021 is happening on Friday, Saturday, and Sunday at 4 again. So 4 o'clock is when I come live daily on YouTube, and these are the days when I have various discussions. Okay, all right. So I hope that helps. Okay. Now, as I was saying, so there has been symmetry in physics. People have discovered a lot of things based on symmetry. So I told you that when people realize that moving charges can create magnetic fields, so they said that can magnetic fields or currents can produce magnetic fields. So they argued that can magnetic fields also produce current. So similarly, in electromagnetic induction, while doing experiments on electromagnetic induction, people realize that varying magnetic fields. So magnetic fields which are varying with time can induce electric fields. So there was an argument, if a time varying magnetic field can produce electric field, can a time varying electric field also produce magnetic field? Turns out yes. So nature seems to be holding symmetry everywhere. Okay, so everything is symmetrical. That is what Maxwell argued about, and Maxwell said that is why a changing electric field would, in fact, be equivalent to a certain amount of current. It would have the same effect, just like currents. It would be able to produce magnetic fields, and this is what he called displacement current. So displacement current is not an actual current, but we consider a time varying electric field to be equivalent to a current, which is being called a displacement current. Okay, now the displacement current is generally given as this. Okay, now you can derive this expression also, how to get the displacement current. So let's go over that. Okay, let's quickly try and see how are we getting this expression for the displacement current. Let's see. So what is happening is, for the sake of simplicity, we will imagine two circular plates of a capacitor. Imagine two circular plates of a capacitor, which is getting charged. So this is getting charged, okay, attached to some battery. Now, at a certain point of time, if I assume that the charge on this is some plus Q and charge on this is some minus Q, then what will be the electric field in the middle? So I can say that the electric field in this region at this instant, if A was the area of cross section of these plates, imagine A was the area of cross section of these plates. So I will say that again, assuming that the size of the plates is very big, compared to the distance between them. So we will always keep that assumption. So assuming size of the plates is very large compared to the distance between the plates. Now, why are we taking that assumption? So that I can use the formula of infinite sheet for figuring out my electric fields. Okay. Okay. All right. So I guess you missed my introduction. Hmm. All right. So let me just quickly tell you here. Now, that is what you want to know about me. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. Okay. For past 8 years, I've been teaching physics for IIT JEE Mains and Advanced examinations. And this had been offline, and I have been associated with some of the topmost institutes that you know of in the JEE coaching industry in offline setups. Okay. I myself was All India rank 447 and All India rank 192. So, like you have mains and advanced. So, we also used to have two papers. In the first paper, I was All India rank 192. In the second paper, I was All India rank 447. Okay. And I've taught many students over the past few years. All right. So, I think that should be good enough for you. Don't worry. Don't worry. I'm more than capable of guiding you to your dream colleges and successful ranks. Okay. All right. So, as I was saying, so assuming that the size of the plates is very large compared to the distance between them, I can make an approximation and I can say the electric field would be sigma over epsilon naught. Okay, so I will write the electric field like that. Now you will also realize that if at some instant the current flowing in the circuit is I, let's imagine some I amount of current is flowing in the circuit. So can I say that? Can I say also sigma was q over a. Now A is constant, A is constant. So can I say from here d sigma over dt, rate of change of the charge density would be equal to dq by dt to 1 by A, correct? Now area is constant. So dq by dt is nothing but the current, right? So I can say d sigma over dt would be equal to I over A, correct? So similarly, if I differentiate it here, if I differentiate that this expression, then I get di dE by dt is equal to 1 by epsilon naught of d sigma by dt, correct? So this becomes dE by dt, essentially coming out to be 1 over epsilon naught I over A. Okay. Now, interestingly enough, what you will realize is that if you think of continuity of charge or if you think about continuity of current, so you see a current I is going from here and a current I is going from here, and it seems to be discontinuous in the middle. So if I imagine that, let's say the current was not discontinuous. If the current was not discontinuous, then I can say all this current can be seen as passing through this region. Okay. So again, we are making an assumption, assuming that fine, the effect of this changing electric field is equivalent to the current. So I can say that the current here would be equal to the entire region. The net current would be equal to the current which is flowing from here and flowing from here because of continuity of current. Okay. So assuming that this current is equal to that, what I realize is that this is what my displacement current is. So we assume displacement current ID to be equal to the current in the external circuit I. So first I will do that, uh, assuming this from continuity of current. Okay, next what I will see is I can now use the expression of Ampere's law. And Ampere's law would have told me if this area was, if this had a radius of r, then from Ampere's law, what I would have gotten is that closed integral of b dot dl should be equal to mu naught times I enclosed. All right. So I would have gotten that b into 2 pi r to be equal to mu naught to I, and I am assuming displacement current to be equal to the external current. Okay, I enclose this I itself. Okay, so that is what we are trying to do. And if I equate this to this equation, if I try to find this equation, then from here I can also realize that I is equal to A epsilon naught dE by dt. Correct? Now, A being the area of cross section does never change. So I can even write this as epsilon times d by dt of E times A. Correct? And E times A is nothing but the electric flux. So I, in fact, can be considered to be equal to epsilon naught times d phi E by dt. So if you have an electric field which is changing, that would cause a changing electric flux through a region or an area, then that can be considered equivalent to this amount of current. Okay. So from any region, if electric field is changing, it will cause the flux to change in that region, and that flux would be equal to the amount of displacement current or imaginary current, which can be related like this. So I displacement, in fact, I displacement, which is the equivalent of equivalent current, uh, which is due to the changing electric field, is given like this. Okay, so this was the expression that I think we had before, right? Yeah, yeah. That is how you can find the equivalent displacement current due to a time varying electric field. Okay, from any region, in any region, if the flux, electric flux, is changing as a dE phi by dt, then the equivalent current, it can be thought that an imaginary current of epsilon naught times d phi E by dt is flowing through that region. Okay, so that is the entire idea. That is how we said that the effects of the time varying electric field is to create currents which is similar to the effect of is to produce magnetic fields which is similar to the effect produced by a current, and the amount of current can be related to the time varying electric field like this. Okay, again, this is an imaginary current. Okay, please remember, this is not a real current. Now the conduction current in the in the circuit, so this should be circuit. The conduction current is the current due to the flow of charges in the conductor, which is denoted by IC. So which I said, in the external circuit, if the current was actually flowing via the movement of charges, then if I'm calling that IC, the displacement current is the current due to changing electric field between the plates of the capacitor and is denoted as ID. Now the total amount of current that will flow through any region would in general be the sum of the current due to conduction of charges and the displacement current, which is produced by the time varying electric fields. Now, including that, Maxwell corrected Ampere's circular law, and he actually gave this expression. So this is Maxwell's correction to Ampere's circular law, and including that correction, Maxwell said that integral B dot dl would be equal to mu naught times IC plus ID. You have to take into consideration displacement current also, and if you write the expression for displacement current like this, then you have this expression. Okay. So this is the corrected form of Ampere's circular law. This correction was suggested by Maxwell. Take care. Now, why don't we practice a problem? Okay. So here you've been told a parallel plate capacitor is being charged. You have to show that the displacement current across an area in the region between the plates and parallel to it is equal to the conduction current in the wires. So how do you show that? Do you show that? I think we already proved that, right? See, Maxwell told us that ID was equal to epsilon naught d phi E over d. Right? If you represent the displacement current like this, So, I already showed you the derivation, but just let's go over that one more time. Now I can replace this. And so I'm going the reverse way. Going in the reverse way. I can write this as this, which again can be written as epsilon naught times A times d by dt, e by dt. Now can also be written as epsilon naught A times uh, sigma 1 by epsilon naught sigma by dt. Okay, this and this gets cancelled, so we can write this as again 1 by A times dq by dt. The circuit. So there you have it. That ID equals IC. Okay, it's just the thing that I showed you in the reverse manner now. Okay, assuming that this is correct, now I can prove that ID would be equal to IC. Okay. Now let's talk about Maxwell's equation. So this is a very important part of the entire electrodynamics. So what Maxwell did was that before, as I said before, earlier we used to think that electricity and magnetism are separate branches. Then definitely Oersted showed us a link between electricity and magnetism, and then they were being looked at together. Now, what Maxwell did was he said that every phenomena of electrodynamics or electromagnetism, that is, can be expressed with the help of just four equations. So those are called the famous Maxwell's equations. So he said that the whole subject of electricity and magnetism can be described mathematically with the help of just four fundamental equations. So the Maxwell's equations are essentially four very fundamental equations which are essentially telling you about the fundamental properties of electric and magnetic fields. Okay, so these equations are based on some basic properties of electric and magnetic fields which never have any violations. And every law of electromagnetism can eventually be derived from these expressions. Okay, so that is something very important. So the first equation is, so it's not like Maxwell gave new equations. He just clubbed four equations and he said these four equations together can describe every phenomena in electromagnetism mathematically. Okay. So the first equation, of course, is the Gauss's law for electric fields. So, this is one of the most fundamental equations that we have. This equation, the integral E dot ds equals Q enclosed over epsilon naught, is valid not only for electric fields produced by stationary charges, also valid for electric fields produced by moving charges, also valid for the electric fields which are induced due to varying magnetic fields. So it turns out that this law is valid for any kind of electric field that you may have. You may have created that electric field from any kind of phenomena, but all the electric fields inherently show this, that always the net flux passing through a closed surface is always equal to the Q enclosed over epsilon naught. Now you know that equations like Coulombs law can be derived from this. Okay, just imagine a point charge is kept here. So essentially, with the help of Gauss law, you can derive the expression for the electric field at any distance r from that point charge, correct? Now, if you have the electric field at any point, now you know the force also between any two charges. Okay, so you realize that Coulomb's law can essentially be derived from Gauss's theorem. Okay, so Coulomb's law can essentially be derived. That is why this is considered to be the more fundamental equation. Okay, this is telling you something about the electric field which never gets violated, while Coulomb's law was limited only to electric fields produced by stationary charges. Okay, you remember that Coulomb's law was only valid for static charges, charges that were stationary. For moving charges, you cannot apply Coulomb's law. However, for moving charges, also for the electric field produced by moving charges, even the electric field produced by time varying magnetic fields, this equation can always be applied. So again, as I said, if mathematically you have this one expression, then you can describe a lot of other equations also related to electromagnetism with the help of this example I've taken as Coulomb's law can be derived from here. Various kinds of electric fields can be derived from here. Now, the second important fundamental equation is called Gauss's law for magnetism, which says that the net flux of produced due to magnetic fields is always zero. Okay, that is essentially lying on the fact that You cannot have magnetic monopoles. So again, a very fundamental property. All magnetic fields which may be produced by any phenomena, whether natural magnets from natural magnets or from currents or from varying electric fields, all magnetic fields always form closed loops and hence have this property. So this tells you that all magnetic field lines always form closed loop. Again, a fundamental property of magnetic fields which is never seen to be violated. Okay, so that is the importance of these equations. These are telling you about some really fundamental properties of fields which you have no exceptions irrespective of what your source of the field might be. Okay, these are not limited to the magnetic fields produced by currents or magnetic fields produced by only natural magnets or magnetic fields produced by time varying electric field also now can produce magnetic fields. So all sorts of magnetic fields will follow this equation. Now again, then the third equation that Maxwell suggested was another fundamental equation was Faraday's law. So Faraday's law tells you that integral E dot dl is equal to minus d phi b by d. There should be a minus sign which is missing. Okay, so that is another fundamental equation. Again, you will never have any exceptions to this. And of course, the fourth equation was the corrected Ampere's law. Okay, so modified. This is not just the Ampere's law. This is the modified Ampere's law. The law that Ampere suggested did not include this. This term was added by Maxwell. So again, this is the fourth fundamental equation for electric and magnetic fields that you have, and it suggests that closed integral of B dot dl equals mu naught times I plus ID, which is the displacement current. If you write the term for displacement current like this, so you can also have this expression. Right? So it is a very important. So I know it may not seem like much, but the contribution of Maxwell was that he said that these are the only four equations that you need in the entire electrodynamics. All the things can be derived from these four expressions. That's it. So he integrated the entire electric and magnetic field theory, and he gave these four equations which can fundamentally describe any phenomena related to electromagnetism. So that was a great achievement. Now, what we do is we will take a look at Maxwell's equations for vacuum. If you are trying to apply in vacuum, then these equations will appear slightly different. So first equation, obviously, which was integral E dot ds. Again, ds is area vector. And this was Q over epsilon naught. Now, in vacuum, the Q would be 0. So for vacuum, Maxwell's first equation becomes this. Okay. Now, how about the second equation? Second equation, you realize, in any case, does not change. This is still the same. Okay. How about the third equation? Third equation, again, remains unchanged. Integral E dot dl, that would be equal to minus d phi b. Okay, because even in vacuum you could have had a time varying magnetic field. Okay, and however the fourth equation gets modified a bit, because in vacuum imagine there is no matter, so you cannot have those currents which are caused by moving charges. So only displacement current can exist. Okay, so the fourth equation takes a slightly different form and it becomes integral of B dot dl equals mu naught epsilon naught d phi e by dt. Okay, so this term basically drops down to 0 in vacuum, and this term drops down to 0 in vacuum. So this is what we have. These will be the Maxwell's equations for vacuum. Now we will use these to determine the relationship between electric fields and magnetic fields, but that we will do in the next class. Today, I think we are out of time. That is all the time that I have for today. All right, but I hope you are getting everything. You're following the introduction and the basics. Now, with the help of this, tomorrow I will find the relation between the electric fields and the magnetic fields. If electric field variations are known, you can actually predict the magnetic field variations, and you can find relations between them also. Okay, so this we will talk about in the next class. So now, because we have run out of time for today, I would like to wrap up today's session. And before I leave you guys, let me remind you one last time. So if you like these lectures, if you think that they are helping you, trust me, then the actual Unacademy Plus courses are going to help you a lot more, and should be getting your Unacademy Plus subscriptions in that case if you're really serious about your preparation. Trust me, this is a highly competitive exam. You will need all the help that you can get. Even if you're starting from somewhere, trust me, extra opportunities never hamper your results. Okay. In fact, this will only better you. So if you're planning to get your Unacademy Plus subscriptions, if you like the lectures here that you see, if you like to enroll in regular courses, then this is how you do it. So you can go to the plus section of the app, select your goal as IIT JEE, and click on the get subscription button. When redirected to the payment page, do not forget to use the code RDLive. If you like my lectures, if you like to enroll in my courses, you can enroll using this code. This will give you a 10% off. Now you can choose from two kinds of subscriptions, plus and iconic. And when you click on proceed to pay, you can get yourself a lot of no-cost EMI options also for payments. All right. So again, moving forward, let me tell you about iconic, because a lot of people do not know about the iconic subscription. This is something. This is a new feature that Unacademy has gotten for you. So the iconic subscription takes your IIT JEE preparation to the next level by assigning you personal coaches. All right. So those of you who have Plus subscription, or if you have any friends who have Plus subscription, they'll tell you with Plus subscription you unlock all the Plus courses, but you are free to choose any course anytime. Okay. So you can select and be a part of any course. You get to be guiding your journey however you want to take it. Here you'll be assigned personal coaches and mentors. Professional mentors will guide you through your journey. Okay. You will be attending a lot of IDJ workshops. You will be receiving expert guidelines. You'll be getting a study planner, and you will get regular test analysis. So they will boost your JEE preparation further with a lot of close mentorship and personal guidance. Okay? Now, a great chance to win yourself the Unacademy subscription is to compete in the next Unacademy Combat Live, which is going to happen on the 20th of December. So if you want to compete and win yourself some cool prizes and test your knowledge and your standing amongst your peers, then you can enroll now using the code RDLive. Go for those quizzes, do well, and win yourself some really cool prizes. Okay. Now, if you like today's video, then don't forget to press the like button, and also share it with as many people as you can, because Unacademy realizes that a lot of students cannot afford these subscriptions. So that is fine. We at Unacademy believe that all students should have access to quality education irrespective of their financial capabilities. So that is why Unacademy is bringing you this quality content absolutely for free, to make sure that more and more students can benefit out of this. It is your responsibility to share these videos. Okay, so keep sharing, spread the love, and let as many people benefit from this as possible. Now, if you're new to the channel, don't forget to subscribe, and keep getting these sessions and quality content absolutely for free. Keep it coming. And now don't forget to press the bell icon so that you're receiving notifications of all the sessions and lectures happening here. And the PDF of all the notes, slides used in today's lecture will be available for download soon. Those of you following us on the JEE English channel of YouTube could also be connecting with us on the Telegram app using this link. So this will also make sure that you're receiving all timely notifications. You're not missing out on any lectures and sessions happening here. Next, before I leave you, this is my code RDLive right there. So if you like my lectures, if you like, a lot of you keep saying, if you'd like to enroll in my courses on Plus, then this is one way of doing it. Get yourselves the Unacademy subscription. Don't forget to use the code RDLive. This will give you 10% off, and will give you all kinds of access to all the Unacademy Plus features. So that is my time for today, and we will continue with this discussion day after tomorrow. All right, where we will see, using Maxwell's equations, we will try and derive a relation between and so trust me, it's going to be interesting. Don't miss that. All right. So I'll see you day after tomorrow. Till then, you guys keep studying hard, keep practicing, and take good care of yourself.